Hello everyone. This talk is to regards how it works in PostgreSQL internal. Thank you for this coming to this session. Uh, Firstly, let me introduce myself. I'm Yugo Nagata and I'm a software engineer at SRA OSS Inc. Japan. And I'm in charge of research and development related to PostgreSQL. Lately, I'm working on incremental view maintenance. That is a feature to enable to update materialized view rapidly and automatically. And recently, we released PGIVM, that is a extension module that provides this feature. And also, I also am lecturer on PostgreSQL internals training, the trainings to explain Postgres internals. So today, I would like to talk about how triggers work in PostgreSQL internals. This talk including what is trigger, what triggers are managed, and how trigger function fired, and how triggers are used in PostgreSQL internally, especially as a relationship to constraints. Well, this is the outline of this talk. Well, first, I'll explain overview of trigger. Well, what is trigger and what the trigger can do. And second, I'll explain how triggers are created and how managed in uh, system catalog and relationship to constraints. And finally, I'll explain how triggers work, especially when triggers are fired and some somewhat complex situation about trigger firing. So let's start overview of trigger. Well, a trigger is a special function that is automatically executed whenever a certain type of operation is performed, and trigger is attached to a table, views, and foreign tables. Well, for example, where some insert or delete or update such a statement is performed on a table. A trigger is fired and a function is executed. Okay. Well, there are many use cases of triggers. For example, uh, you can make an audit trail of logging, and you can invalidate input date before the data is inserted to the table, or you can enforce or check constraints on some tables. Also, you can generate some business data according to your some complex business rules. So, well, when a trigger is fired, well, in January, trigger is fired after or before insert, update, or delete, or truncate statement. In addition, well, copy from command is command to insert some rows to table. So when copy from command is performed, insert trigger is fired. And merge command that is introduced in PostgreSQL 15. This command performed insert, update, and read in it. So merge commands also fire triggers. Well, there are two types of triggers. Per row or row level trigger. This is invoked once for each row that is affected by the statement, and another is per statement or statement level trigger. This is invoked only once when an appropriate statement is executed. Note that insert, delete, update trigger created for two both types. But triggers on blanket may only be defined at statement level. So, what trigger function can do? Generally, trigger can scan and or modify as a table. So you can generate some business data to the other to as a table, and trigger can refer to the old and or new row record if the trigger is defined as row level triggers. So you can use triggers to audit logging and so on. And trigger also can modify the row being inserted or updated. So you can use trigger to some tricks on the command itself, or also you can skip the operation itself if the trigger is defined as row level before trigger. Also, you can raise an error in the trigger in order to avoid a transaction. And also, you can refer to transition tables in trigger functions. Transition table is a set of affected rows. There are two types of table. Old table has a before images of all rows updated or deleted, and a new table is after image of all rows updated or inserted. The transition table can be used in after triggers for statement level or row level triggers. Well, and also, you can create a triggers on build, and you can use instead of triggers to update a complex builds. Well, in PostgreSQL, simple view is automatically updatable, but complex view, including join, cannot be automatically updated. So, but if you create it instead of triggers on view, you can update it. You can update the view from the trigger function by modifying its base tables. Well, however, this talk is focusing on triggers on table. So the detail of instead of triggers are not explained in this talk. So next, I'll explain how triggers are created. You can create trigger using create trigger command. Well, in this example, the trigger named check update is created as each row level statement for update statement, and this is fired before update, before each row is updated on table accounts. If the table is updated, before each row is updated, the function check account update is executed. This trigger function must be defined before creating trigger. So yes. And also you can specify condition about when the trigger is fired. In this example, where the balance column, column named balance, okay, well, the trigger is fired only if the balance column has in fact changed. And when you create a trigger, entry is created in PG trigger system catalog. This entry contains trigger name, trigger type, and condition, and transaction table names, and so on. And also, this entry has a reference to tables that is managed, that is stored in PG class system catalog, and also PG trigger has a reference to PG proc. This contains a entry for function to be executed. Well, about trigger, this is a kind of trigger called constraint trigger. This is a trigger for implementing constraint. Constraint trigger must be low level after trigger. Basically, constraint trigger is the same as a regular trigger, but the difference is the timing of the trigger firing is different. There are two types of timing. When the trigger is the constraint trigger is fired at the end of the statement. This is called immediate. And if the constraint trigger is fired at the end of constraint transaction, this is called deferred. Constraint trigger defined as deferrable can be deferred constraint triggered. So you can create constraint trigger using create constraint trigger statement, this command. In this case, the constraint trigger named check constraint is created as a deferrable, and this trigger is initially deferred. So this trigger is fired at the end of transaction. Well, the firing timing can be changed using set constraints commands in the transaction. When the state constraint is changed deferred, you can change the constraint to deferred, or you can change the constraint to immediate using this command. Okay, constraint trigger are related to constraint. So constraint trigger, when constraint trigger is created, also constraint entry is created in PG constraint system catalog, and such relations are stored in system catalogs. Well, you can create constraint using this command, but you create constraint triggers also created internally in PostgreSQL for when creating some constraint. One is foreign key constraint or differential integrity. And another is when creating primary key, unique, or exclusion constraint as deferrable constraint. Okay, well, this is an example of foreign key constraint. There are two tables, orders and order items. And order items has a column order ID. This column is referring to this column has a foreign key that references primary key of order table. So when a new record is inserted to order items table, we have to check the same key value is the key value exists in orders table. And on the other hand, if record in orders table is deleted in this definition, the same key record in order items table must be deleted in cascade. Such actions and check and actions are implemented using constraint triggers. When such constraint is created, such triggers are created. So when some key is inserted or updated in order item tables, this constraint trigger is fired, and such functions executed, and checked if the key exists in orders table. And when a record in orders table is deleted or updated, such trigger is fired, and such functions are executed, and if needed, the row is record in order items are decoded, or maybe an error is raised, and transaction will be aborted. And for primary key, unique, and exclusion constraints, if such a constraint is defined as not deferrable, such constraint is checked when unique constraint is checked when a new unique index entry is inserted. And execution constraint is checked at when a row is inserted in the executor. If such a constraint is not deferrable, no constraint triggers are created. But if such a constraint is created as a deferrable, constraint triggers are created, and such a constraint are checked using such a triggers. That is at the end of statement or at the end of transaction, where the trigger on the table is fired, and the check function is executed, and table index is table is as a record in the table is checked. So if the constraint is violated, an error is raised and the transaction will be aborted. So as I explained here, some constraint triggers is related to index. So if such a constraint triggers are created, also their relationship between index relation to index also stored in system catalog. So okay, this is a way to create triggers and manage trigger in PostgreSQL. Okay. Next, I'll explain how triggers work in PostgreSQL. So especially I'll explain when triggers are fired using example of update. Suppose their table, this is a table like this, and update statement is performed on this table. Where if the flag is 1, the value column is updated. So before the statement starts processing rows, statement level before trigger is executed immediately. And after that, the statement starts processing rows in table. And then the first rows that whose flag is 1 is found. So before the row is updated, row level before triggers for ID 3 is executed. And the row is updated. Then after the row is updated, row level after trigger is not executed here. The row level after triggers for ID3 is just saved in the trigger queue, waiting queue. And the old record and new record is stored in transition table, each transition table, old table and new table. Then other process for other next rows, the same thing is same processing is done performed. Where for ID 4 and ID 6 rows, row level before triggers are executed immediately, and row level after triggers are saved in this queue, and were records stored in transition table, each transition table. And when the update statement ends processing rows, where the statement level after triggers is queued, stored in this queue. After that, queued after triggers are executed in this order row level after triggers ID 3, 4, 6, and statement level after triggers. Such after triggers can refer to transition table. The contents are collected during the statement execution. So, you can create multiple triggers for the same event on same region, and such triggers are fired alphabetical order by name. So, for statement level before trigger, statement A, B, C is executed in this order, and row level before trigger for row 1, for row 2, and so on. And after row level after triggers and statement level after triggers, each triggers are fired in alphabetical order by name. So what are deferred constraint triggers? This explanation is about regular triggers. But for deferred constraint triggers, such deferred constraint triggers are not executed at the end of the statement. Instead, such a triggers are just moved to the other trigger queue for the transaction. Where, for example, there were in the trigger queue, there are immediate after trigger and deferred after trigger, and statement level after trigger, and when at the end of the statement, immediate trigger and settlement after triggers are executed at the timing. But deferred triggers are moved to another queue for the transaction. And at the end of transaction, such triggers in this queue are executed. Also, deferred constraint trigger in this queue is executed when the state is changed to immediate. Set constraint commands can be executed in the transaction. And when in this example, when this statement, at the end of the statement, the deferred after trigger are not executed. But before end of transaction, this constraint is changed to immediate by set constraint command. So this trigger is changed to immediate and executed at the time immediately at the end of set constraint command. Well, this is the internal behavior of deferred constraint triggers. Here I'll explain about triggers and transaction. Well, triggers are executed as part of same transaction as the statement that triggered it. So this is regardless of whether it is deferred constraint trigger or this is not immediate regular triggers. So that statement and trigger are executed in the same transaction. So if either the statement or the trigger caused an error, the effect of both statement and trigger will be rolled back. So in constraint trigger function, if trigger this function notice that some constraint is violated, the, the trigger function will arise an error to roll back the transaction. Okay. At the end of the final part, where I'll explain some complex situation about trigger firing. One is insert on conflict to update statement. Well, this insert statement is special because when a conflict occurs, the statement perform update instead of insert. When this command is performed, statement level triggers for insert and statement level triggers for update. Both of them are executed for before and after. And when a row is inserted successfully, the row level trigger for insert this row is executed before and after. However, some row is tried to insert, but the row cannot be inserted due to the conflict. Only row level trigger for insert is executed, but only for before. Before that trigger is executed only before insert. Instead, also the row level triggers for update command is executed for both before and after, because the row is the actual action is update, not insert. Or are somewhat complex. And next example is merge. This is more simple. Merge command is introduced PostgreSQL 15. This command can some delta table to this command merge delta table to this table. Okay. Well, with regard to this command, statement level triggers for insert and update and delete are executed for both before and after, if such each command are specified in merge command. If that command is not specified in merge, the statement level trigger of this command will not be executed. Well, oh, sorry. And for row level triggers, row level triggers are fired only if the actual the row is actually inserted or updated or deleted. In this case, this record is inserted. So row level triggers for insert is executed for this row, and this row will be updated. So row level trigger for update will be executed, and this row will be deleted. So row level trigger for delete is executed for this row. And finally, I'll explain triggers of partition table. Well, this is an example of range partitioning table. Range partitioning. This is a root partitioned table, and there are two partitions. Partition 1 is for key value between 1 and 10, and table 2 is a partition for key value between 11 and 20. And this update statement try to change key value 3 to 7. The affected partition is only this partition table 1. So in this case, statement level triggers for update is executed on this root partition table for before and after. And low level triggers for update is executed in this partition because only this partition is affected by this statement. On the other hand, this is another example with moving tuple record is moving between partitions. The key value 7 is changed to 14. Well, in this case, same as before, statement level triggers for update are executed on the root partitioned table for before and after both. And update is executed in this partition table 1. So low level triggers for update is executed in partition, but before trigger only, because the actual command is delete and insert. That is, a row, this record is deleted from this partition, and this record is inserted in this partition. So record is moved. So low level triggers for delete is executed in this partition before and after both, and insert low level triggers for insert is executed in partition before and after both. Okay. This is the end of my presentation. Let me summarize. I'll explain what is trigger functions. Trigger function is automatically executed whenever a certain type of operation is performed. So there are many use cases. So you can use triggers in your application for audit logging, make a business data, and make a complex constraints. And also, triggers are also created and used in PostgreSQL internally as a part of constraint implementation, such as foreign key constraints, primary key, unique constraint, and exclusion constraint. And and I explained how triggers are fired, especially when triggers fired in and this firing order. And finally, I explained some complex, some situations that where triggers behave somewhat complexly. This is all of my presentation. So I hope my presentation will help you imagine how a trigger is working inside of your PostgreSQL. Thank you for listening. Thank you.